2. The gradient factor, the significance of the gradient factor. Significant. This is the gradient factor. I'll put an arrow here so that it looks like a vector. Sometimes it does not look like the arrow, but okay. We know that the directional derivative of the function in the direction of the unit vector is the dot product of the gradient vector and the unit vector. So from the definition of the dot product, we can work it out a little further. So this is the magnitude of the gradient factor multiplied to the magnitude of the unit vector cosine of the angle. Yeah. Okay. So what do we have here? We just have a magnitude of the gradient factor cosine of the angle. So far so good. Well, cosine of the angle is between 1 and -1. What do we know here? We know that the directional derivative is between negative the magnitude of the gradient factor and positive magnitude of the gradient factor when to 0 tell us that the two vectors parallel. Yeah, we see that maximum rate of change is gonna be the magnitude of the gradient vector. Let fxy equal. Actually, let me box this thing because this is a pretty nice formula too. X ey a find the rate of change of f at the point 2, 0 in the direction from the point 2, 0 to the point 1 over 2, 2. It can be find the direction in which f had max rate of change I need to find okay, same thing, right? We got to get the gradient factor, huh? Ey and then this can be x ey gradient vector at 20 scalar. Yeah. Okay. 20, right? Okay. Plug it in. Oh, how nice. E to the power 0. 2e to the power 0. Right? So what do we have? We have a 1, 2. Ah, nice. Next step is that we're going to figure out the vector. From 2, 0 to 1/2 to 2. Right? So I'm going to let that one be v. V is the vector. It's just that 1 point minus the other point. Yeah. You know, you can turn a point into a vector. 1 over 2, 2 minus 2, 0. And that will give us the negative 3 over 2, 2. V over the magnitude of the vector V. So that's V. Oh man. Yes, fraction is just have to write a little smaller here. Square root of negative 3 over 2 square plus 2 square, and this would be negative 3 over 2, 2 over. Oh, what do we have here? We have a 9 over 4 plus 4. Oh man. Oh, root of 25 over 4. So that'd be 5 over 2, right? Okay. So divide by 5 over 2 is the same as time 2 over 5. So it's 5 over 2. So this is going to be 2 over 5. So it's going to be a negative 3, 5 times 2 over 5. So 4, 5. Okay, so got that. Right. Radiant vector dot the unit vector. No, gradient vector 1, 2 dot unit vector negative 3, 5, 4, 5. So it's the negative 3, 5 plus 8 over 5. Oh, how nice. It turned out to be a nice number. 5, 5. Just 1. 2, 0. And that is 1, 2. Direction in which F have max rate of changes. The magnitude. Oh. So this is going to be the max rate of changes. Okay. Example. Let's fx, y, z be the pressure at XYZ, where fxyz equal to, we know fxyz is the density function, is family of surfaces, but it can be seen as pressure, temperature. Okay, that's something so that you guys can practice on. Find the rate of change of pressure. At 1, 0, -1 in the direction up. The vector 1, 2, 2. Okay, so it can be find the direction that has the maximum rate of change in pressure and the maximum rate of change of pressure. And the maximum rate of change is in pressure. At, well, 1, 0, -1. I think by yourself you can do this one. I want to do another question here, quick one, see if you you understand this. But if you stand on the surface, fxy equal 4 plus x squared plus 3y squared. Let's say you stand on the surface there, right? Which direction would you move to? Which direction would you move to ascend the fastest? At 2 -1/4 35/4 is where you stand at. The answer here is the 4 -3/2. Hopefully you see that you want to go the fastest, but it has to be the gradient factor. And at the point 2 -1/4. 4 and -3/2. 3. Yeah. So what is a level surfaces there? A level surfaces is the a level surfaces. A level surface is a surface in a form fx, y, z equal k. This is a level surface of the function fx, y, z. Okay, so now how do we figure out the tangent plane and the normal line? It's like cool. Let's see. Be any curve or trace on S that pass through the point x naught, y naught, z naught. If you have this one, then you can use a vector function to describe C. We can use or T, xt, yt, zt to describe C. fxt, yt, zt equal k. Next step is that we're gonna differentiate with respect to t. Differentiate with respect to t, then it's going to be a, well, you're going to use the chain rule. Remember, on one side it's going to be the chain rule. Fx x prime t plus fy y prime t plus fz z prime t, and it is just 0. Okay, so what do we know? Well, we're going to be using a dot product. That is the same as the dot product of fx, fy, fz dot x prime t, y prime t, z prime t. And it is equal to 0. Amazingly, it's equal to 0. If it's equal to something else, then it's not significant at all. Okay, so what do we know about fx, y, z? This is the gradient vector. Dot. What is this one? It's the tangent vector. They are perpendicular to each other. Yeah. And the gradient vector is also D. a particular orthogonal to each other, orthogonal. And a lot of people would use orthogonal because this is a better term, you know, this is surfaces there. Well, if they are orthogonal to each other, then the gradient vector is also the, anybody? From your math 1C. The normal vector, very good. Yep, by yeah. And the gradient vector is also the normal. And because we have the normal vector, we can have the equation of the tangent plane and the normal line. I'm going to underline this thing because it's very important. The gradient vector is the normal vector. So make sure you know that. That is very important in chapter 16. Okay. If t equal t naught, then or t sub 0 is equal to x naught, y naught, z naught. Well, equation of tangent plane to level surfaces, the equation of tangent plane is going to be this one. If you guys remember equation of tangent plane, then you just have to replace the normal vector as this. Fx x naught, y naught, z naught, x minus x naught plus fy x naught, y naught, z naught, y minus y naught plus fz x naught, y naught, z naught, right? Z minus z naught equal to 0. Equation of normal line. RT. So RT here is going to be a x naught, y naught, z naught. This factor plus t, right? And then this one would be a fx, fy. Oh man. X naught, y naught, z naught, fy, x naught, y naught, z naught, fz, x naught, y naught, z naught.